Hi, hello everybody. What we are going to have right now is we are going to talk about sequence. So what is a sequence? Sequence are terms that shows pattern. So to understand clearly, I have illustrated here examples of sequences. We have example number 1, 4, 7, 10, 13. Example number 2, we have 5, 10, 20, 40. Number 3, we have 1/2, 1/6, 1/18, and 1/54, and so on and so forth. These are what we call the example of sequences because it shows a pattern. Let's take for the example number 1. If you're going to notice, we only add 3 to obtain the next term. We add 4 plus 3, we get 7. 7 plus 3, we get 10. 10 plus 3, we get 13. So there is what we call a pattern. And the same with number 2, there's also a pattern because we only multiply it by 2 to obtain the next term. We have 5 times 2, we get 10. 10 times 2, we get 20. 20 times 2, we get 40. If I will be asking what will be the next term, yes, the next term will be 80. The same with number 3, number 4, and number 5. You are going to notice all of these examples shows pattern. And since this is a pattern in mathematics, there are what we call sequences. And there are 2 kinds of sequences. Example 1, 2, and 3 are what we call finite sequence. And example number 4 and 5 is what we call an infinite sequence. Why do we call 1, 2, and 3 finite sequence? It's because it has a first term and a last term. A last term here is 13. The same with number 2, it has a first term and a last term. The same with example number 3, it has a first term and a last term. So that makes it a finite sequence. But in example number 4 and number 5, we call that one infinite sequences. Why? Because it does not have a last term. The 3 dots that you can find in number 4 means it will not end there. So it's unending. So that makes it infinite. So if you're going to look at number 5, n here represents as any number. You just substitute the value of your n. But still, there is still no ending or no last term. So this makes it an infinite sequence. So for example, if you are given a general rule and then you are asked to find its first 5 terms, first 20 terms, and so on and so forth, this is how we do it. Find the first 5 terms of the sequence with a general term a sub n equals n plus 5. Here is the solution. N here represents as any number or the number of terms. So n could be any number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on and so forth. But since we're only going to look for the first 5 terms, therefore, we're just going to use n as 1, 2, 3, 4, 5 as a number of terms. So how are we going to solve for the first term? So we just substitute our n by 1. Our general rule is a sub n equals n plus 5. We just substitute our n by 1. N by 1. So a n will become a sub 1 equals n will become 1 plus 5. So just simplify. So the answer will become 6. The same with our second n, our second value of our n, number of terms. We'll just substitute our n by 2. So this will become a sub 2 equals, the n will become 2 plus 5. So just simplify 2 plus 5, we get our answer, which is 7. The same when n is equals to 3. So this will become a sub 3 equals, we just substitute our n by 3 plus 5 simplify, we get our answer 8. And a sub 4, when n is equals to 4, this is n equals to 4, we just substitute our n by 4. So n plus 5 will become 4 plus 5. Our answer is 9. And when n is equals to 5, so this will become n plus 5 from our general rule. This will become 5 plus 5 equals 10. So therefore, the first 5 terms of our sequence are 6 as our first term, 7 as our second term, 8 as our third term, 9 as our third term, and 10 as our fifth term or last term. So we call this one first term, or can be written as a sub 1 as first term. And this one is our last term, could be written as a sub 5. There are different kinds of sequences, and one of those is arithmetic sequence. So what is an arithmetic sequence? You will know that one as we go on with the examples. The examples are number 1, 6, 7, 8, 9, 10, and so on and so forth. Number 2, 5, 10, 15, 20, 25, and so on and so forth. Example number 3, 1, 4, 7, 10, 13, and so on and so forth. What have you observed with our given arithmetic sequence? Yes, if you're going to notice, to obtain its next term in example number 1, we just add it by 1. So there's what we call the pattern. How about example number 2? Still the same. We just add the same number to obtain the next term. And we add, yes, it's 5. 5 plus 5 will give you 10. 10 plus 5 will give you 15. 15 plus 5 will give you 20. 20 plus 5 will give you 25, and so on and so forth. And the same with number 3. We just add what? Yes, we just add 3 to obtain the next term. 1 plus 3, we get 4. 4 plus 3, we get 7. 7 plus 3, we get 10. 10 plus 3, we get 13, and so on and so forth. So what is an arithmetic sequence? Yes, an arithmetic sequence is a sequence whose next term is obtained by adding the same number, called the common difference. What? It's called a common difference. A common difference is that number we add to obtain the next term. So how are we going to get the common difference? It's just easy. You just subtract the second term by its first term. You just subtract the third term by its second term. If the difference of these two are the same, therefore, or they have what we call a common difference. And they are an arithmetic sequence. So you want to try it? Let's try example number 1. Our second term in example number 1 is 7. 7 minus the first term is 6. The answer is 1. Our third term, first, second, third term is 8. We just subtract it by our second term, which is 7. The difference is 1. If you're going to notice, they have a common difference. So, if they have a common difference, then it is called as arithmetic sequence. Let's proceed with number 2. In number 2, still the same. We just get our second term minus the first term, our third term minus the second term. So we are going to get our second term. Our second term is 10. So 10 minus the first term is 5. So 10 minus 5, we get 5. Our third term is 15. So 15 minus 10, our answer is 5. Still the same, they have a common difference, and their common difference is 5. So therefore, example number 2 is an arithmetic sequence. Last but not the least is number 3. 1, 4, 7, 10, 13. Our second term is what? Yes, it's 4. Subtract it by 1, we get 3. Our third term, subtract by second term, our third term is 7 minus our second term, which is 4. Our answer is still the same, which is 3. Their common difference is 3. Therefore, example number 3 is also an arithmetic sequence. Do you understand now what is an arithmetic sequence? Yes. We are going to have another example to deepen whether you understand it or not. So my last example, is this arithmetic sequence or not arithmetic sequence? Let's try to find it out. To know whether it is an arithmetic sequence or not, we have to get its common difference. So how do we get the common difference? We only get our common difference by subtracting our second term minus our first term. The same, we subtract our third term minus our second term. We can also subtract our fourth term minus our third term, and so on and so forth. If the difference of these are the same, therefore, we can conclude that this sequence is an arithmetic sequence. So we'll try to answer it. Second term minus first term. Our second term is -7. Minus our first term is -2. Since there are two negatives, so we'll put parentheses. So -7 minus -2 equals. Applying the rule for subtraction, we change the sign of the subtrahend and proceed to the rule of addition. Or you can multiply both negatives, negative times negatives. So that will become -7 plus 2. We get our answer. -7 plus 2, we get our answer, which is -5. So the difference for second term minus first term is -5. How about our third term minus the second term? Our second term is, our third term is -12 minus our second term is -7. Of course, there's still two negatives. We just separate them by parentheses. So -12 minus -7, applying the rule for subtraction. So we get that one as -12 plus 7. So we get our answer. -12 plus 7, rule for addition. They have different signs, so you subtract and then you copy the sign of the bigger number. So the bigger number, we have negative, we have 5. The difference for third term minus the second term is still the same, -5. And last but not the least, we have fourth term minus the third term. Our fourth term is -17 minus our third term is -12, so we'll put parentheses. So -17 minus -12, so this will become -17 plus 12. So our answer will still be -5. Therefore, if you're going to notice, they have the same difference. So they have what we call a common difference. So since they have a common difference, so the question is this arithmetic sequence or not arithmetic sequence? So the answer is yes, it is arithmetic sequence. Do you understand? Very good. That's it for today, guys. Thank you for watching and see you on next video. Please subscribe. This is your teacher, Julie, of course, signing out.